Now, today we are going to differentiate molecular formula and empirical formula. We don't know what is empirical formula, but we know what is molecular formula. After knowing the difference, we are going to solve one question: how to find empirical formula and hence molecular formula. So, what is molecular formula? We already know. Molecular formula represents exact number of different atoms present in a molecule. How many atoms present in a molecule of each kind of atom is shown by molecular formula. For example, in H2O, we can easily get that 2 atoms of hydrogen and 1 atom of oxygen is there. Similarly, in hydrogen peroxide H2O2, we can get the idea that 2 atoms of hydrogen and 2 atoms of oxygen are there. So we are getting that how many numbers of atoms of each elements are present in a molecule. So this is represented by molecular formula. Molecular formula represent exact number of different atoms present. Okay, but empirical formula is something different. Empirical formula is found from simplest ratio of the atoms present in a molecule. By getting the simplest ratio of the atoms in a molecule, we can easily form empirical formula. You can compare molecular formula and empirical formula by taking one example. Molecular formula of hydrogen peroxide is H2O2. Now we will get the simplest ratio of the number of atoms present. So here it is 2:2. We can easily simplify 2:2 again into 1:1. So 1:1 is the simplest ratio of atoms present in hydrogen peroxide. So using that simplest ratio, we will form the empirical formula. That will come H1O1, or you can write HO. So this is the empirical formula for hydrogen peroxide. Similarly, you can take example of glucose. Glucose, we know molecular formula as C6H12O6. Now form the simplest ratio of all the atoms. It will come 6:12:6. We can simplify further. It will come 1:2:1. Now using the simplest ratio 1:2:1, we are going to form the empirical formula. Then that empirical formula will be C1H2O1, or you can simply write CH2O for glucose. So this is the difference between molecular formula and empirical formula. Molecular formula represents exact number of atoms present. Empirical formula gives the simplest ratio of all the atoms present. Now, how to calculate empirical formula and hence molecular formula. So this is a concept map. Using this we are going to solve problems. How to get empirical formula and hence molecular formula. For example, in a question it is given that mass percentage of each elements in a compound is given, and if molar mass is also given, means in a question if mass percentage of all the elements given and molar mass of the compound is given, then how to calculate empirical formula and hence molecular formula. So this is the concept map. So if mass percentage of element is given, so mass percentage means we will get the given mass, how much mass of the elements is there. So from there we will get the number of moles, because we know the expression number of moles equal to given mass by molar mass. So number of moles can be calculated using this relation. Given mass, from where we will get? We will get from mass percentage of elements. Given mass, we will get from mass percentage of elements. And molar mass we already know for all the elements. So using this, we will calculate number of moles of each element. Since this number of moles represent the simplest ratio, we can easily form the empirical formula. Getting that simplest ratio of the atoms in the form of number of moles, we can form the empirical formula. Now we know how to calculate molecular mass. Now using that empirical formula, we will calculate empirical formula mass. How we used to calculate molecular mass from molecular formula? Here also we will calculate empirical formula mass from empirical formula. You have to just put the values of atomic mass of all the elements present there and you have to add up. So after getting empirical formula mass and it is given molar mass of the molecule is given. So using both of this we can easily calculate N. N, what is N here? N is calculated as molar mass whole divided by empirical mass. So molar mass we already know, it will be given in the question, molar mass. Empirical mass we have to calculate from empirical formula. So using this relation we can easily calculate N. And what is the use of N? N is very vital for calculating the molecular formula. So what is the use of N? Here you can see what is the use. There is a relation between molecular formula, N, and empirical formula. Since we are going to form the molecular formula, so molecular formula equals to N into empirical formula. So in this way we will form empirical formula. From there we will calculate molecular formula. With the help of one problem, we can easily understand this concept map. Now here is the question. A compound contains 4.07% of hydrogen, 2.27% of carbon, and 71.65% of chlorine. What is this percentage? Percentage of hydrogen, percentage of carbon, percentage of chlorine. This is nothing but the mass percentage. How much mass of hydrogen is present? How much percentage mass is present in a compound? So this all percentage represent mass percentage of element. And it is also given molar mass. Molar mass of the compound is also given. It is 98.96 gram. Now you have to calculate empirical and molecular formula. So in this question, two things are given. One is mass percentage of all the elements and second is molar mass of the compound. So using these two things, we are going to formulate empirical formula and molecular formula. First of all, what is given mass percentage? Let us write that. So given mass percentage of hydrogen is 4.07%. Mass percent of carbon is 24.27%. Mass percentage of chlorine is equal to 71.65%. As we know the meaning of percentage, we can easily tell that 4.07 gram of hydrogen is there in 100 gram of compound. Percentage means out of 100, we know. Percentage means out of 100. So here 4.07 percentage means 4.07 gram of hydrogen is there in 100 gram of compound. So we are taking the mass of compound be 100 gram, then the mass of hydrogen will be 4.07 gram, mass of carbon will be 24.27 gram, and mass of chlorine will be 71.65 gram. From percentage, we are getting the mass. So what is this mass? This is the given mass, because we are going to calculate number of moles. So in calculation of number of moles, we have to use given mass. So this is the given mass. Given mass because it is given in the question. It is not the molar mass or the molecular mass. So this is the given mass. As we have to calculate number of moles, we should know the formula. It is given mass by molar mass. So let us write what is the molar mass of same elements, hydrogen, carbon and chlorine. So molar mass of hydrogen we know 1 gram, molar mass of carbon we know 12 gram, molar mass of chlorine we know 35.5 gram. So given mass is there, molar mass is there, we can easily calculate number of moles. So let us calculate number of moles. Number of moles of hydrogen will be equal to given mass of hydrogen 4.07 gram, molar mass of hydrogen 1 gram. So it will come nearly about 4. Now number of moles of carbon, given mass of carbon is 24.27 gram, molar mass of carbon is 12 gram. You will divide and you will get near about values equal to 2. Now number of moles of chlorine, given mass by molar mass, that will again come as near about value 2. Now what is the ratio we are getting? Ratio of hydrogen is to carbon is to chlorine. Ratio of hydrogen is to carbon is to chlorine. What we are getting? 4 is to 2 is to 2. But we can simplify this ratio again. So it is not the simplest form. We have to simplify it again. It will come 2 is to 1 is to 1. So this is the simplest ratio. And we know using the simplest ratio we can form the empirical formula. So what will be the empirical formula? 2 is for hydrogen, so empirical formula will be H2 because 2 is for hydrogen. Carbon how many? Carbon 1, so C. Chlorine is 1, so Cl. So it will come as H2CCl. You can arrange this and can write as CH2Cl. Okay, now after calculating empirical formula, we have to calculate empirical formula mass. Okay, we know how to calculate empirical formula mass similarly like that of molecular mass only. So it is CH2Cl. C mass is, atomic mass is 12. 2 hydrogen are there. 1 atom of hydrogen is mass is 1 gram. So 2 into 1. 2 into 1 is 2. Chlorine atomic mass is 35.5 gram. So you will have to add up. You will get 49.5 gram. So here using mass percentage, we are taking out given mass. We know the molar mass. Using given mass and molar mass, we are calculating number of moles. From number of moles, we are forming the ratio of the different elements. We are simplifying the ratio in the simplest form. Then we are using that simplest form to form the empirical formula. Now using that empirical formula, we are calculating empirical formula mass. So what we have to do next? We have to calculate molecular formula. So next we have to calculate N. Now in the question only it is given molar mass of the compound is 98.96 gram. So what is N? Because to get the molecular formula we have to calculate N. So how to get N? N having the expression molar mass by empirical mass. Molar mass will be given in the problem only, and empirical mass we have calculated. So put the values. It will come 98.96 whole divided by 49.5 gram. So near about value it will come 2. So N value is 2. Now there is a relation between empirical formula N and molecular formula. So molecular formula equal to N into empirical formula. So put the value of N and empirical formula. 2 into empirical formula is CH2Cl. Now you have to just do the multiplication. C2 H 2 into 2 will be 4 H4 Cl2. So for molecular formula we are getting C2H4Cl2. So this is the molecular formula. So in the whole process, using the mass percentage, we have calculated given mass. And we know the molar mass. So using given mass and molar mass, we have calculated number of moles. Then we find the simplest ratio of all the moles of the elements. Using that simplest ratio, we form the empirical formula. After forming the empirical formula, we calculated empirical formula mass. Using that empirical formula mass and molar mass from the question, we have calculated N. Using that N and empirical formula, we have calculated molecular formula. You can recheck the answer also. You just calculate the molecular mass of C2H4Cl2. If it come 98.96 gram, then your problem solving is correct. The problem you have solved will be correct. If the molecular formula we are getting, you have to calculate the mass of that molecular formula. That will come molecular mass. That mass should match with that of molar mass of the compound. Then your solution will be correct. Now moving on to the next topic, a new topic. Limiting reagent. From the name itself, it is clear that the reagent is going to put a limit on the amount of product formed from a chemical reaction. Limiting reagent means that reagent is going to limit the amount of product that is going to formed through a chemical reaction. So what is limiting reagent? Limiting reagent means in a chemical reaction, the reactants which is present in a lesser amount. In a chemical reaction, the reactant which is present in a lesser amount gets consumed, and as it gets consumed, it will put limit to the amount of product formed. Whatever amount of other reactant you are adding, that will not harm the amount of product. That will not increase the amount of product because the lesser amount of product is getting consumed totally. So limiting reagent is the reagent that limits the amount of product formed irrespective of the amount of other reactant. For example, if 100 ml of H2 is reacting with 50 ml of O2 to produce 100 ml of H2O, then the reactant which is present in lesser amount will get consumed after a short time. Now, if you keep on adding hydrogen, oxygen is totally consumed. Now, if you keep on adding hydrogen, does it forms more product? No, it will not form more product because oxygen is already finished. So whatever the amount of other reactant, that will not harm the amount of product. That is not going to increase the amount of product because the lesser amount reagent, the lesser amount reactant is already consumed. So that lesser amount reactant will be the limiting reagent. So what is limiting reagent? In a chemical reaction, the reactant which is present in lesser amount, gets consumed totally and put a limit on the amount of product formed, irrespective of the amount of the other reactant. It will be more clear if we solve a problem on this. Now this is a concept map how to identify a limiting reagent during a chemical reaction. If there is a chemical reaction, how we are going to identify the limiting reagent and how we are going to calculate the amount of product. Okay, so this is the concept map. We are going to solve one problem based on this, but first go through this concept map. First of all, as it is a chemical reaction, first we have to write the balanced chemical reaction. First we will write balanced chemical reaction. Then if mass of reactants are given, that will be the given mass. Mass of reactant given means that will be the given mass. And we know already how to calculate molar mass. So then we will calculate number of moles using that given mass in the question and the molar mass that we already know. Now after getting the number of moles of reactants and products, so that time we can compare number of moles reacting in balanced chemical reaction and number of moles present. There are two things. There is a balanced chemical reaction, so there are number of moles, fixed number of moles that are reacting. So we have to compare that number of moles with the number of moles that we are calculating using the given mass. So both of this we have to compare. It will get more clear if we solve one problem we will do. So just make a concept to compare with that problem. So we will compare number of moles in the balanced chemical reaction and whatever number of moles we are getting by putting given mass by molar mass, that formula. After that, reactant with less number of moles will become limiting reagent. As we know, limiting reagent means the reactant with less number of moles, because it is going to put a limit on the chemical reaction or on the amount of product. It will limit the amount of product. Whatever be the amount of other reactant will not going to increase the product. But this limiting reagent is going to put a limit on the amount of product. So from there, after comparing the number of moles with balanced chemical equation and number of moles we are calculating, we will get that which reactant is having less number of moles. That reactant will become limiting reagent. And one thing you should note down in your copy, that limiting reagent decide the amount of product. We know there are many reagents that combine together in a chemical reaction, but the limiting reagent only decide the amount of product. There are many reactants during a chemical reaction, but the limiting reactant will decide the amount of product. So you should note down this in your copy. This is the main point of very vital point of limiting reagent. Now after identifying the limiting reagent, we are going to calculate the amount of product formed from limiting reagent, because limiting reagent decide amount of product. So using this relation we can easily calculate the amount of product. So let us go to one problem that will make it more clear. Here it is given 50 kg of nitrogen gas and 10 kg of hydrogen gas are mixed to produce NH3 ammonia. Here you have to identify the limiting reagent, and as we know, limiting reagent decide the amount of product, hence we will calculate the amount of product formed. Here product is ammonia, because here nitrogen is reacting with hydrogen forming the product ammonia. So we will use that limiting reagent to calculate the amount of NH3. So first of all we have to identify limiting reagent. How to identify? So first our work is to write the balanced chemical reaction. Here reaction is between N2 and H2. So N2 is in the gaseous form plus H2 it is in the gaseous form, and it is a reversible reaction, so I am using this sign, reversible sign. It is forming which product? Ammonia, NH3. It is in the gaseous form. Now you balance the chemical reaction. You know how to balance any chemical reaction. There are 3 hydrogen there, and here 2 hydrogen. So you put here 3 and before NH3 you put 2. It will balance that equation. N2 gas reacting with H2 gas to form ammonia, NH3. Now after balancing the chemical reaction, here masses are given of the reactants. So write down the given mass of the reactant. So given mass of N2 nitrogen is 50 kg, given mass of H2 is 10 kg. Convert it into gram because we are going to solve in gram only, because molar mass is generally we used to keep in grams. So we have to convert this in gram first. So after converting the given mass into gram, we are going to calculate number of moles. First work is to balance the chemical reaction. Second work is to calculate the number of moles using that given mass in the question and the molar mass that we all know. So first of all we will calculate number of moles of N2. So given mass of nitrogen is 50,000 gram, and molar mass we know nitrogen N2 means 14. Atomic mass of nitrogen is 14 and 2 atoms are there, so 14 into 2, 28. So if we divide, it will come nearly about to 1785.7. Since in a scientific notation we should keep that capital N between 1 to 9, so we are moving that decimal before 7. So it will come 1.786. I am rounding off this 57. So 1.876 into 10 to the power 3. Why 10 to the power 3? Because we are moving the decimal 3 places to left side. So it is 10 to the power 3. Now calculate the number of moles of H2 hydrogen. It will come, given mass is 10,000 gram and molar mass we know 2 gram, because one hydrogen atomic mass is 1. So there are 2 hydrogens, so 1 into 2 it will come 2. So if you divide, it will come 5,000. So it is, I am putting in scientific notation form, it will become 5 into 10 to the power 3. Now remember this. Okay, remember this number of moles of N2 and number of moles of H2. We are going to use this further. Now here I am writing this equation again to make it easy to understand. Now here in the balanced chemical reaction, you can see 1 mole of nitrogen is reacting with 3 moles of hydrogen to give 2 moles of ammonia. We know how to make a statement of a chemical reaction. We have already learned that. So here we can say 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of ammonia. So I am writing this only, 1 mole of nitrogen required 3 moles of H2. 1 mole of, to form the ammonia I am writing this, From that balance equation only I am writing. 1 mole of N2 require 3 moles of H2. So we have already calculated number of moles, given number of moles. So you have to put that. Given number of moles we have already calculated. This line is from that balanced chemical reaction. So one point in the concept, ma'am, is that we have to compare the number of moles from the balanced chemical reaction with that of number of moles actually present. Okay, so here we are comparing. Here first of all we are writing the statement of the balanced chemical reaction. 1 mole nitrogen gas reacting with 3 moles of hydrogen gas. So we have to compare this with the present number of moles. So we have already calculated that 1.786 into 10 to the power 3 moles of nitrogen will require, now 1 mole of nitrogen is requiring 3 moles of hydrogen. So this much moles will require 3 into this unitary method. So this much moles of hydrogen is required. But we have calculated already number of moles of hydrogen. There it comes 5 into 10 to the power 3. That much moles of hydrogen is present. But here it is coming this much moles of hydrogen is required. So we are not having this much of moles of hydrogen. We are having less than that because we are having near about 5 into 10 to the power 3. It is more than 5, 5.36. That much we are not having. So this hydrogen will become the limiting reagent because it is present in lesser amount. Whatever amount is required here, it is not present. It is only 5 into 10 to the power 3 moles. So it is whatever required, it is not there. That's why dihydrogen H2 will become the limiting reagent. How much amount is required is not present over there. It is present in lesser amount. So it will decide the amount of product as it becomes the limiting reagent. Since we know limiting reagent decide the amount of product, so we will make a relation between hydrogen and product. How much hydrogen is required to make the product? That relation we will take. Note that limiting reagent decide the amount of product. Here we got the limiting reagent hydrogen. So it will decide the amount of hydrogen will decide the amount of ammonia. So we will make relation between these two. Here 3 moles of hydrogen require 2 moles of ammonia. 3 moles of hydrogen is required to produce 2 moles of ammonia. I am writing this from the balanced chemical equation. First line always we will write from balanced chemical reaction. Then we will put the given values. So first I am writing from balanced chemical reaction. 3 moles of hydrogen will produce 2 moles of ammonia. 3 moles of hydrogen will produce 2 moles of ammonia. So follow the unitary method now. So 1 mole of hydrogen, how many moles of ammonia will produce? 2 by 3. That much moles of ammonia will produce. But actually how much amount of hydrogen we are having? We have calculated already how much amount of hydrogen. We are having only 5 into 10 to the power 3 moles. So 1 mole, this much of mole will be produced. So 5.0 into 10 to the power 3 moles of hydrogen, how much ammonia will be produced? 2 by 3 into 5 into 10 to the power 3. If we solve this, it will come nearly about 3.3 into 10 to the power 3 moles of ammonia. So what we have did till now, we first identified the limiting reagent. Using that limiting reagent, we are getting how much number of moles of ammonia will be produced. But we have to calculate this number of moles, this amount of ammonia. We have to convert this number of moles of ammonia into grams. So how we are going to convert this? We already know the relation. So we are going to use that. See, we know 1 mole of ammonia, how much mass? N is 14, atomic mass of N is 14. Atomic mass of 3 hydrogen is 3 into 1. So in total it will come 17 gram of ammonia. So in 1 mole of ammonia, how much gram? 17 gram. So how much moles we are actually having of ammonia? We have calculated just now. We are having 3.3 into 10 to the power 3. Follow the unitary method. So 1 mole this much. So 3.3 into 10 to the power 3 moles will be 17 into 3.3 into 10 to the power 23. That much gram. So if we solve this, it will come 56.1 into 10 to the power 3. That much gram of ammonia. Since we have to write in scientific notation, so we can change into kilogram also. So in kilogram we have to divide by 1000. Gram to kilogram conversion we have to divide by 1000. So 1000 will get cancelled with 10 to the power minus 3. So it will only come 56.1 kg of ammonia. Why we are converting in kg? If you don't convert, it's okay. But why you're converting in kg? Because in the question only, the reactant amount is given in kilogram. So we are converting in kilogram only. So this is one problem based on limiting reagent. So first of all, we have to identify limiting reagent. And after the identification of limiting reagent, we will calculate the amount of product. Because amount of product depends upon that limiting reagent only, that limiting reactant only, not on other reactants. That means ammonia, here it is forming ammonia. This ammonia production will be depend on hydrogen, not on the amount of nitrogen. Because nitrogen is not the limiting reagent, hydrogen is the limiting reagent. So amount of ammonia will depend on hydrogen, not on nitrogen.